this lecture video, we are going to talk about requirement specification. So what is requirement specification? Specification is the process of writing down the users and system requirements in a requirements document. We have already defined what do we mean by user requirements, system requirements, functional requirements, and non-functional requirements in the previous lecture videos. Ideally, the user and system requirements should be clear, unambiguous, easy to understand, complete, and consistent. In practice, however, this is difficult to achieve as stakeholders interpret the requirements in different ways, and there are often inherent conflicts and inconsistencies in the requirements. Let's start with user requirements. The user requirements for a system should describe the functional and non-functional requirements so that they are understandable by the system users who do not have detailed technical knowledge. Ideally, they should specify only the external behavior of the system, and the requirements document should not include details of the system architecture or the design. Consequently, if you're writing user requirements, you should not use software jargon, structured notations, formal notations, and so on. Preferably, you should write user requirements in natural language with simple tables, forms, and intuitive diagrams. Let's now talk about how to write system requirements. System requirements are nothing but an expanded version of the user requirements, and these are used by software engineers as the starting point for the system design. They add detail and explain how the user requirements should be provided by the system, or how does the system provide or implement the user requirements. They may be used as a part of the contract for the implementation of the system and should therefore be a complete and detailed specification of the entire system. Ideally, system requirements should simply describe the external behavior of the system and its operational constraints. They should not be concerned with how the system should be designed or implemented. However, at the level of detail required to completely specify a complex software system, it is practically impossible to exclude all design information, and this is because of the following three reasons. First, you may have to design an initial architecture of the system to help structure the requirement specification. The system requirements are organized according to the different subsystems that make up the system. This architectural organization is essential if you want to reuse software components when implementing the system design. So this is why you cannot totally exclude the initial architecture of the system in your requirements document. Second, in most cases, systems must interoperate with existing systems, which constrain the design and impose requirements on the new system. Thirdly, why it is not possible to totally exclude design information is because the use of a specific architecture to satisfy non-functional requirements might become important. An external regulator who needs to certify that the system is safe may specify that an already certified architectural design is being used. So in this diagram, you can see the different ways of writing a system's requirement specification. You may use natural languages completely. In this case, the requirements are written using numbered sentences in natural language. Each sentence should express one requirement. So every requirement is a bulleted sentence, numbered preferably, and each of them expresses a single requirement. Second, structured natural language. The requirements are written in natural language on a standard form or template where each field will provide some information about an aspect of a requirement. Third way of writing requirements is design description languages. These use languages like a programming language, but again with more abstract features to specify requirements. Next, graphical notation. Graphical models supplemented by text annotations are used in order to define the functional requirements for system. For example, use cases written in UML, sequence diagrams, and so on, which we will study in detail in the next module. Mathematical specifications. Formal mathematical specifications are sometimes used to describe the requirements for safety or security critical systems, but are rarely used in other circumstances. These notations are based on mathematical concepts such as a finite state machine, set theory, and so on. Let's look at the natural language specification. Firstly, why use natural language to specify requirements? Natural language has been used to write requirements for software since the beginning of software engineering. It is expressive, intuitive, and universal. It is also potentially vague, ambiguous, and its meaning totally depends on the background of the reader and how he interprets what is written. As a result, there may have been many proposals for alternate ways of writing requirements. However, natural language still continues to be one of the most widely used way of specifying system and software requirements. In order to minimize the misunderstanding, it is recommended that you follow these simple guidelines whenever you're using natural language. First, invent a standard format and ensure that all requirements definitions adhere to the format. Standardizing the format makes omissions less likely and the requirements much easier to check. Secondly, use language consistently to distinguish between mandatory and desirable requirements. Mandatory requirements are the ones that the system must support and implement and are usually written using the word shall. Desirable requirements are not essential and are written using the word should. Next, use text highlighting, bold, italic, or color to pick out key parts of the requirements. Next, do not assume that readers understand technical software engineering language. It is easy for words like architecture and modules to be misunderstood. You should therefore avoid the use of technical jargon, abbreviations, and so on. Next, whenever possible, you should try to associate a rationale with each user requirement. The rationale should explain why the requirement has been included. It is particularly useful when requirements are changed as it may help to decide what changes would be undesirable. In this slide, you can see the example requirements for the insulin pump software system. Only two requirements are used here. If you want the complete requirement set, it is available at the link provided in this slide. So you can read through these two requirements numbered and written in a completely natural language specification. Next, what about structured specification? Structured natural language is a way of writing system requirements where the freedom of the requirements writer is limited because it's not a natural language, English type language writing style, and all requirements are actually written in a standard way. This approach maintains most of the expressiveness and understandability of natural language, but ensures that some uniformity is imposed on the specification. Structured language notifications use templates to specify system requirements. The specification may use programming language constructs to show alternatives, iterations, may highlight key elements using shading or different fonts. Now let's look at what information needs to be included when we're using a standard form. First, description of the function or an entity which is being specified. Second, description of the inputs and where these inputs come from. Third, description of the outputs and where they go to. Fourth, information about the information that is needed for computation or other entities in the system. Fifth, a description of the action to be taken. Next, if a functional approach is used, a precondition setting out what must be true before the function is called, and a postcondition specifying what is true after the function is invoked and executed. Last, a description of the side effects, if any, of the operation. To understand a structured approach to specifying system requirements, you should define one or more standard templates for requirements and represent these templates as structured forms. In this diagram, you can see the standard way or standard template or form used to specify requirements in a structured way for insulin pump control system. The function is to compute the insulin dosage, The description of the system is defined here. Inputs, the source of the inputs, outputs, where these outputs are destined to go, the action that has to happen, the requirements, precondition, postcondition, and side effects. You can go through the slide and understand this in more detail. So what are the advantages of using structured specification? Using structured specification removes some of the problems of natural language specifications. Variability in the specification is greatly reduced because you have a structure in place and you have to write description only to the fields in that structure or form, as we have seen in the earlier slide. Requirements are organized more effectively. However, it is still sometimes difficult to write requirements in a clear and unambiguous way, particularly when complex computations are involved. To address this problem, you can add more information to the natural language requirements. For example, add more tables, graphical models, and so on. Tables are particularly useful when there are a large number of possible alternative situations and you need to describe the actions to be taken for each of these alternate situations. If you look at this figure here, it's a tabular format of what has to happen or what is the action based on different conditions. Because the condition part is not just one condition, there are multiple conditions. So sugar level falling, then what you have to do. Sugar level stable, then what you have to do. Sugar level increasing, then what you have to do, and so on. Based on a condition, an action is specified in a tabular column. So in this lecture video, we have seen the importance of requirement specification. We have also seen how requirements can be written or the system requirement specification can be written in a wide variety of ways. We have seen why natural language specifications are still most widely used and what are the limitations with natural language specifications. We have also seen how structured specification can be brought into place in order to overcome the disability of using natural language specification. Thank you.